So why does code style matter? Your code is written once, read many times, modified many times, often not by the original author. And even if it is by the original author, you won't necessarily remember why you did this. So the goal is to write code which is easy to read and understand, to mainly avoid bugs and avoid the difficulty to modify and the challenges in reusing. When you are reading the documentation of all of the helper functions you're using from the libraries, they usually have very detailed commenting, and that's why. Today, I'm going to cover guiding principles, aspects of coding style. In terms of functions, variables, comments, avoid duplicate code, group data with classes and structs, no warnings. And all of these will be graded by your TA, and others are optional in this course. Guiding principles. We need to write code that reduces cognitive load for people reading your code. Your human working memory has, by Miller's law, 7 plus minus 2 items at once. So you won't be remembering more than those number of items at once. Therefore, if you need to remember a lot of things while reading your code, it's going to be very difficult. But if you have all of those in comments, you don't have to remember all of those. So try to minimize the number of considerations at a time. Your code explains how you're doing things, but usually not why. So you need to write down why in your comments or in the other aspects like variable names. The original writer knew why you wrote the code like that, but usually you can't ask them or the original writer might forget about it. So explain why. Usually I would read a chunk of code and I think if I write this in another way, maybe it's simpler, but why did it not be written in the other way at the first place? So I have to ask the first author if it's not already written in the comments. Functions, variable names, temporaries. Write short functions. Google says most functions should be 40 lines or less. When your TA grades your coding style, they will see whether the function can fit in one screen. Unless it's absolutely necessary for it to be 2 screens. And more than that, they will deduct marks. Long functions are hard to read, understand, and maintain. And if you are forced to write shorter functions, you will need to name parts of code, organize structured code into multiple helper functions. The functions overgrow over time. If every one of you thinks you just need to add 2 more lines to this function, for 10 times, this is 20 more lines to the function. So when you are writing, if you need anything like copy and pasting, consider refactoring to new helper functions. Variables. Good variable names describe the content and purpose of the variable so that this avoids the need for commenting, over commenting. So the reader does not need to look at the declaration and initialization often in another file. Temporaries and scope minimize the number of variables in scope. So this reduces the number of things you need to remember at once. In a smaller scope, you just need to know the variables that are just in this scope. But be mindful of temporary variables, only add them that help readability and add information. If they don't add on readability and information, if they just simply rename variables, don't do that. Now let's look at this function. This is a relatively simple function, and it's written to not be misleading, and all of the variables make sense. But let's take 1 minute to read it, and then can anyone tell me what this function does? Give you 10 more seconds. Okay, can anyone tell me what this function does? It's some integration function. How about this one? Nothing's changed. It's just renaming some variables. It's a definite integral from x left to x right. We're having the step size as 10 to the minus 4. Integral is added in each iteration of the for loop. And in the for loop, we are incrementing x by step size. And the function we're integrating is 1 over x. In the original function, definite integral, when you're writing it, this makes perfect sense. And in the integral, we are integrating from a to b. This follows the integral definition function formula. The d is delta, makes perfect sense for integrals. We have x, x2, y. And at first, the value itself is 0. And we do x from a to b, incremented by the step size. So writing more in the variable names really helps on quickly getting a grasp of what this function does. So naming conventions for variables make descriptive, often multiple words, variable names. Within your group, discuss whether you want to use underscores to separate words or use camel case. This should be universal within your code, all the code you write. You should either use underscores or camel case. For constants, discuss amongst your team whether you want to use starting with a K, camel case, or all capitals. Yes. Yes, just for variables. For the functions that you need to implement, yes, the names are fixed. Yeah. Only for the names you are making. Doesn't matter. And variables names and function names shouldn't be using the same naming convention in the first place. For type and class names, always start with capital. And now we have this chunk of code of find street segment length for a street segment. Any thoughts on the coding style? Yeah. So it has no comments. And anything else? Yep. But your variable naming convention and the function naming convention shouldn't be the same. Should not be the same. Or if you decide to keep them the same, I guess it's fine. Just for the classes, you need to capitalize them. How about if there are any lines, empty lines between chunks of code? There are no vertical white space, so it's very crowded to read. Break your code into paragraphs of related code. Group related code together so that your eyes are not getting tired reading your code. There are many function scope variables that are only used once in one of the if or else statements. So some of them are not even required to be function scope. They just need to be within the if or the else block. This could be a cause to many potential initialization bugs. Like length is only used in if. This first, this last are only used in else. So declare variables at the smallest scope possible where they can be initialized. Now we move the variable initializations inside the if and else. The variable names are not very descriptive. When we are initializing inter1 and inter2, we are assigning those to info.from, info.to. But in this case, the from and to information are lost in your renaming. And this gets propagated later into lat long. And there is a redundant temporary variable length. For this length, why do you declare a length variable and then return, rather than return find distance between 2 points directly? So we rename the variables ID to street seg ID, info to seg info. This is the information of a street segment. We don't need the inter1, inter2. We put them directly into the parentheses. lat long 1, lat long 2 to call position from position 2. See, we already shortened the function by a lot. And we reduce the use of redundant lengths by directly returning from find distance between 2 points. How about these two variables? Are they redundant temporary variables? If we get rid of pulse from, pulse to, and directly put them into the find distance between 2 points, this gets the return line very, very long, and this is not necessary. Sometimes the temporary variables can help improve our readability and add information, and allows you to better see your steps in the debugger. So if you step through the debugger like this, you might need to do a lot of step into at this single line. But if you are doing it here, you can know which function you're stepping into, which line. So we went from before to after. We reduced a lot of not necessary stuff, and what we are doing are still the same. And this code is a lot readable than this code. Is this okay? Now, comments. We're going to go through types of comments, which are more or less important to include in your code. At the top of all of the files, especially header files, you have to have this comment block saying what this header file contains, what this file is used for, how you can use it. In your .h file, each function header needs to have a description of what this function does, unless it's very clear in the name. In front of each struct or class definition, you will need to have a block comment saying what this class is, how to use it. In your .cpp, for every code block, group your code into code blocks, and for every code block, have a comment. In these cases, which are the most important? So your comments should have the documentation of your code in there. You shouldn't be keeping your documentation in a separate document because it will get out of date very easily. The most important comments are the ones that gives the big picture of your code from the top level. And that describes the why. Why are you implementing the code like this, not in another way? And why the overall structure? Why are you choosing the overall structure, the design choices, and stuff? Where to comment? Like what I just showed, the top of files have a block of comment. In front of the class and data structure definitions, have a block of comment. Because usually understanding the data structures understands how you implemented the program. The declaration of functions in header files, how to call it, what it does. And in your code itself, comment on tricky code. If your code is already very clear, you don't have to add a comment there. You don't have to translate clear code to English like that. Do not leave commented out code in your project. Your TA will check for that. Git has all your code history if you need to get code history like that. But before you submit, make sure you deleted all of the commented out code. And the comment importance are like this. Most important comments are the ones at the top of files, and then before the data structure definitions. And then the declaration of functions. Now let's look at this definite integral code again. What comments we want to add to this function? Because it's already very clear by the variable names. We add a block of comment at the top of this definite integral of 1 over x function, saying that we compute the definite integral of 1 over x between x left and x right via the trapezoidal method. Smaller values of step size improve accuracy but decrease computation time. See, we have this line, smaller values of step size improve accuracy but increase computational time. This line describes why you are making this design choice and how you can improve it in the future. Is this good? And then inside the function, you don't have to have anything here. Instead of, you just need 2 comment lines describing what these 2 pretty tricky lines does. And that's it. There's a problem in the slide. I'll fix that later. And that's it for comments. Any questions till this point? Just remember, it's not as much function is better. As much comments is better. Put comments where they have to be. Duplicate code. Always avoid duplicate code. And try to extract them into their own functions. Because it's likely copy-pasted by the programmer. And if you fix the bug in one of the copy and pasting and you didn't fix the others, common source of bugs. Let's see this for loop. So we are having the for loop that loops through the num segments, 3 segments. And we are finding ss.from and thus ss.to. These 2 code blocks are almost identical. It's just we are switching from ss.from to to. So we can extract the duplicate code into a function. And this improves readability as well. Because after we move that into a function, insert unique, we can see that we are doing something insert unique here for intersection 3 segments, ss.from, and on the SSID. comments. We extracted the code into two functions, but we kept the comments the same. Are the comments looking good or not? The comments are a bit wordy and repetitive because the function itself already is describing itself. So we can combine the two calls to the two functions into one code block and just say we add street segment if it is not a duplicate. And this means for both from and to. And that's basically what we are expecting from your coding style. And now let me show you a demo. So in this folder, I have the m1.cpp with the find street segments of intersection already implemented from the last tutorial. And for this demo, I'll show it once in code, VS Code, and once in NetBeans. Let's look at the code. So we have the global variable intersection street segments. What's the problem with the coding style here? Actually, I'll show you it passes the test first. So the 2 of 3 failed. So this means the only function we implemented is passing. So this code passes. What's the problem with the code? Yeah. We need some white space, yes. I'll add some white space. What else? Yep.
Not that application as education, some information necessary. It's still hard to read that there was a for loop, nested for loop.
So the indentation and the spaces are not correct for the for loop. So what I'm going to do is in VS Code, you can do this. Highlight and format selection. I'll do that again. I highlighted this chunk of code. I right-clicked and I say format selection. And this will fix the indentation and white spaces. Anything else? Yeah. We need to add comments. But I won't do it now. How about the variable namings? They're bad. So in VS Code, what you can do as a trick, highlight and then Control D will highlight all of the nums in this case, but this is not intelligent enough. So, and in this case, if you want to rename, you can go num intersections. And this should go rename all of the nums, but okay, it's only letting me highlighting one more now. And another trick you can do in VS Code to rename the variables, you can do rename symbol. And this will intelligently choose the names within the scope for this variable and rename them. And I'll do the same thing for all the other ones. So this I is the intersection. This is getting slow because of VS Code. Okay. The X is the number of intersection street segments, so I'm just making up my own names. Within your group, you should be having a unified naming convention. J is the something like this. So now we have renamed all of our variables. There's another thing in this code that we should be doing. Can anyone tell what's the other problem in this code? So remember, we're in load map now. So if you need to load one global variable in load map for one of your functions, and if you keep all of those inside load map, your load map is going to be enormous. So whenever you are loading one specific variable, make a helper function and call the helper function in load map. And unfortunately, VS Code doesn't have the option right now. Like our VS Code doesn't have the option to refactor out the code into a function. So you have to do it manually, and I'm not doing it now. But there is the function in NetBeans. So I'm just going to save, make, and run the test again to show that I didn't change anything for the code itself. It's just the variable names. Okay, I'll revert the code back to where it was. And I will open NetBeans and do the same thing. One.cpp. So this is the same position in the code. And what we need to do first is to format the load map function. In NetBeans, right-click, format. And this will fix all of the indentations and white spaces. You might need to fix your vertical spacing yourself. Variables. We want to rename the num to be num intersection. So right-click, refactor, rename. This does exactly the same thing as VS Code. Refactor, and this will do the renaming of this variable within this scope. Same for I. Rename to be intersection I. Rename X to be num set I. And I'll rename the J to be seg J. That's the renaming. I renamed everything as before. And now I want to refactor the loading of this intersection street segments global variable in the load map to a helper function. In NetBeans, I'll highlight the code, right-click, refactor, introduce function, and I'll give the function a name to be fill intersection street segments. And what this does, it will call the fill intersection street segments here, where the code was, and it introduces this function with the code that we had. And then you will need to add the comments. Is this fine? So the refactoring of functions is only working for NetBeans for now. It's not working for our VS Code version. I'll save it and I'll compile and run the test through. So we didn't break the test. And that's it for the first IDE. Oh, I just reverted back the code. The next very big thing for coding style is to not use magic numbers. We keep emphasizing this, but every year I'll see someone using magic numbers in their code. Use named constants, not magic numbers. In this code, we have 20 samples. We are looking for, if they're positive, we return 1. If they are negative, -1 or 0, or 0 numbers. In this code, you can see that we are using a magic number 20 for the 20 number of samples. If you need to change the array size in the future, you'll have to change all the occurrence of 20. And it's returning magic numbers -1, 0, and 1. So you must read the code carefully to see what each number means in this case. What we want to do is to define constants for the number of weights, 20, at the beginning. You can either do it like constant int number weights as a constant variable, or you can do a preprocessor constant define weight 0, 0. Both ways are valid, and you can choose whichever one you prefer. The -1, 0, and 1, because they are grouped a grouped comment, grouped constants, because they can be grouped together because they are return values. You can use an enum of the return value type. So you're defining an enum type that contains these 3 constants with a name given to each of them. If it's just something like a 0, you don't have to rename 0, but for everything else, give them a constant name. All 3 ways to make constants work. You can do whichever way or a combination of 2 or 3. And if you do a enum type of the return type here, you can return the enum type directly so that the compiler will guard that it's not returning anything else other than 0, 1. 0, 1, -1. Is this okay? Second demo, eliminate warnings. So we have the same chunk of code in here. And I'll first disable the warning in the make file. So in the make file, in your compile flags, these 2 compile flags are for warnings, for displaying warnings. Now I'll disable them by commenting out and without any warning flags. So the compilation will only give errors, not warnings now. Let me make clean and make. So it finished successfully, there's no errors. Let's do check numbers. For this code. So the numbers we're looking at are -1, 2, 3, 4, 5. So there is a -1 here. So the check weights function should be returning as net, which is -1. Right? Give me some reactions. Yes. But when we are running the program, it's giving a 1. And we have no idea why. So now let's go to the make file and enable comments. Enable warnings, sorry. Make thing and make. Oh, we have one warning. At line 11, warning suggests parentheses around assignment used as truth value. So we have an assignment operator here. But our intention is to compare weight I with 0. So we're missing one equal sign here. Without that warning, it's very easy to find. It's very hard to find without the warning. This and this. And now if we compile, there's no warnings. And if we run, there is -1. If you missed part of the tutorial because of the CI meeting, I have the recordings posted afterwards. Take a seat. So the target for your code is to have no warnings. Do you not have any warnings in your code? Warnings like what I just showed flags potentially problematic code. But if you leave some of the warnings that are not so important in, you might not be able to see the new ones. So the actually helpful ones could be buried inside all of the warnings that you're leaving on. So stay at 0 warnings at all times. Our makefile already has all of the warnings turned on. And your TA will be checking the number of warnings in your code. If they're seeing not a 0 warning, it will lower your style mark. Group related data into classes. This is not so too much enforced, but this is a good habit to have. Say you have these 4 global variables of vectors. And all 4 of them are for street segments. What we have here is a class that contains segment data that has the 2 integers, 1 float, and 1 double. And in this case, we only have to have 1 global variable for the vector of segment data. And in this case, because we only have 1 single global variable, it's not polluting the name for global variables. so that more names can be reused. And if you want to access any of those, you can just access inside segment data using the dot convention. Defensive coding is the last part. So you don't have to do defensive coding in this course. Your TA is not going to deduct any marks if you don't use it. Defensive coding is the coding style that allows your code to find errors for you without even having to write unit tests. Use assertions to verify the assumptions in your code. For example, if you are assuming that this function is passing in an intersection ID that is from 0 to number of intersections minus 1, using an assertion statement to check whether that is the case. And if at any time it's not passing in a valid intersection ID, your assertion will fail and your program will stop at that point, and your program will tell you that it stopped at this assertion. This is better than comment, yeah. It makes it slower, and I'll tell you how to disable it. So this checks at runtime and will give useful error message because it tells you exactly where it stopped. Define and debug will disable the assert checks. So if you use this right before submission or checking for performance, all of the assertions will be disabled and your runtime will be back to normal. Another defensive coding that should always be maintained is when you are deleting some pointers. In case this pointer will be used in the future, in case you are not directly exiting that class or function, set the pointer back to null. If you don't set it back to null and you use it accidentally afterwards, it will give you very weird errors. And if you set it back to null, you're guaranteed to have a segfault immediately. And more advanced techniques are writing self-checking code for verifying the key data structures, which are not required in this course. And to just avoid something like this. So you don't result in this, you will be segfault or assertion check failed before getting this. Now, the last assertion demo. To use assertions, first we'll need to include the assert.h header. And then in this find 3 segments of intersection, we add the check for intersection ID, the validity check for intersection ID. And now I'll show you some trick that might be very useful for you. I'll go to the terminal. I'll make first I'll run the ECE297 tester just to show that the assertion is not firing because we're getting all valid intersection IDs. Now, if I change the run tester to debug tester, look at my files when I do this. We got these. And in my files, I have new files in the tests folder. I have a new test folder popping up in my repo. And inside the tests folder, it has the source code of the test that I just ran. And this is the functionality intersection Toronto test. So intersection queries public Toronto, Canada. That's the base structure for the test. And I have the test fixture for the intersection street segments. And I have two more text fixtures that we have not implemented yet. So I will delete them for now because we're only looking at the intersection street segments. I'll save this. I'll go to the make file. Look at the configurations I'm setting. I'm going to unit test debug. Build target is still all. Launch target, I'll set it to test libstreetmap. This will be making unit test in debug mode. And I will be launching the unit test itself rather than matter. So in this case, I passed one test and there's only one test available. And now with the assertions turned off, I'll do the on one first. With the assertions turned on, go set one of the intersection IDs to -1. I'll build and run. This will tell me that the assertion intersection ID greater than or equal to 0 and intersection ID less than intersection street segment size failed. But if I say I define the end debug flag here, and this turns off the assertion. Build and run again. This only fails the test. And this error is failure in intersection street segments, unhandled exception. In ECE297 check equal expected sorted. Find three segments of intersection -1. And that's the difference. And this is how you will be getting the source files for the unit tests and how you can modify them. Is this clear? Am I going too fast? Good. So assertions will make your code run slower, but and debug will disable the assertions so that your code speed is back to normal, just to repeat. As a summary, your code will be read more than written by you, by others. So make it readable. And make it readable in a short time. You won't have a lot of time just reading the code. Your code will be modified many times. So avoid repeated code and large functions. keep the tests with the code so that it's automated whenever you build and whenever you run. Keep documentation in the code by using comments, and have a good habit of having code reviews with everyone in your group. Read each other's code and discuss what is readable, what is not. Google says changes not committed visible until reviewed, or approved. And we have the milestone 1 project management and code style rubric on purpose that you are able to look at. It's not the full set of coding style that we covered here. There are additional resources on coding style if you want to read more about it. And that's it for today. Any questions?